And our next speaker is Kai Vogel, coming from Germany, from the well-known company Viprotron. And he will talk us about new technology for a precise and repeatable measurement of distortion after the furnace. I think after the nickel sulfide, the optical distortion is definitely the second hot item of tempered glass.
Thank you very much, Francis, for your kind introduction. Actually, I would like to start my presentation with a question to all toughened glass manufacturers in the audience. So, what do you think, what could be an interesting, challenging vision in terms of quality of the tempered glass to you as a fabricator? How this vision, quality vision, could look like? And in very interesting vision could be to be able to produce permanent, excellent tempered glass quality. I think that sounds great. And the next topic comes now, even independent of qualified furnace operators. But we all know how today's reality look like. So glass facades are, in many cases, full of distortions. And we all know that it looks not so nice in the facade. And we all know also that the existing furnaces still produce visible distortions. And it is extremely difficult and complex to optimize the furnace today. At the same time, customer expectations rise all the time. They always want better quality. But without reliable measurement and experienced operators, it will be difficult to get over this kind of issue, quality issue. So new solutions must deliver precise and repeatable measurement results. They are the key for advanced furnace optimization. And here are some key takeaways you will take from this presentation. So first of all, you will learn what makes the true edge distortion technology so unique. Therefore, I will present several measurement results right from industrial glass fabricators. So some case studies. Based on that, you will understand immediately the big benefits for both for glass processors and architects. And I will conclude my presentation with the outlook, what will come next in terms of optimization and automation. So during this presentation, you will clearly understand how to take a significant step forwards to this vision. Before I dive into the true edge distortion technology, I will give you some bull parts here. So the technology is providing a high resolution mapping of the distortion. And it includes a patented edge-to-edge scanning technology, which removes blind spots near the glass edges. So this technology provides real edge kink results without missing anything. And those results, for example, those edge kink results are extremely important for reliable further lamination process. Furthermore, it is capable to identify all kinds of distortions. Doesn't matter, edge kink, roller wave, pocket saddle, however you call it, deformation. So this technology can be a key for advanced furnace optimization, reliable laminating, and to be able to achieve architectural standards, also in your production. Let's dive into the technology itself. So the technology consists of two important factors. The first one, and this is a unique one in this industry, the technology works with line scan cameras. I'm not quite sure if the audience is familiar with the line scan camera, but if you implement such kind of camera, the image is looking completely odd, what you get out of this image. Because it sees only a scan line with a high resolution, but only just one line. And as long as the object is not moving, you see nothing in the image. But when the object starts moving, suddenly you get a very precise image, and the camera at the same time needs to be able to acquire those images in a really high speed. So if we go back to the furnace, you can say the speed of that camera is reaching 10,000 scans per second. And based on that, this technology is able to generate a very precise and dense information about the distortion. And it is capable to start right at the glass edge, because there's nothing missing here. The second point is the way how to make the deformation visible. And for that we are using a specific triangle light pattern, which consists of black and white triangles. So when we do have here a perfectly flat glass, the camera and the light pattern, which are positioned right in reflection, so the camera looks right into the center of those pattern. And now when the glass is traveling through the camera and the camera is generating the image from the pattern, what do you think, how would the image look like? I think it's quite a simple answer. You will receive just very simple, straight black and white lines. With a flat glass, you will see just straight lines. Now, the algorithm is calculating the spacing between those lines and confirm it into the distortion levels. So ensure with straight lines, the result will be 0 millidiopter, because the glass is flat. But when we now run a glass with deformation through the system, what do you think how it can look like now, the image? First of all, as what you can see here, the scan line, the red scan line, moves up and down in the pattern. And the result will be thick and thin lines from the pattern as an image. And again, the algorithm is measuring the spacing between those lines. And based on that, he then transforming it to the distortion. And based on that, it generates a really precise result of distortion. So with this kind of technology, you reach a distortion resolution of plus minus 4 millidiopter, which is unique in the industry. At the same time, every 0.5 millimeter, the actual distortion is measured. So you will receive a really high dense information from that measurement regarding the overall deformation in detail. But how was everything proved and tested? And now we come first to the first testing we did together with a certified lab. So we were bringing several pieces of glass to the lab, 1 by 1 meter. They have equipment, specific measurement equipment, tactile based, which is controlling all kind of different objects and measuring the 3D data tactile. So this equipment consists of a granite table. It's installed in a air-conditioned lab, and you can get from there the highest precision what you can find. So, and we wanted to compare it with the measurement results of the true edge technology. So we run through those glasses 30 times through the measurement device and compare it here. And what you see here on the graph is the black line is the tactile measurement coming from the lab. And the blue crosses are all the measurements taken from the measurement equipment. And as you can see here, there was an extremely high, or there is extremely high conformity reached with a very low deviation. Second, we wanted to compare the numerical numbers which has been measured from both. And we split it into the distortion values in millidiopter and the peak to valley values in millimeters. So on the left side, the tactile results, and on the right side, the results coming from the true edge. And again, we reach an extremely high conformity here, which with a near perfect match. Doesn't matter which area we are looking at, leading, center, or trailing edge. There was a very, very low deviation here. And now we come to the field test. An industrial glass fabricator, Eckel Glass from Austria, they have been performing an intensive test after implementing this technology behind their furnace. They really wanted to see how precise and how reliable it is. And what they did, they took a glass out of their standard production of tempered glass and run it through the equipment in 3 different sections. On the left side of the conveyor, on the right side of the conveyor, and in the middle section of the conveyor. And on each side, they run the glass through 10 times to see the repeatability. And here are the results they generated for the peak to valley values in millimeter out of this test. So those are all the records that they took. So in blue, left side, red, center, and in green, the right side. And again, each area, so front edge, trailing edge, and center edge. And on the green line here, you can more or less see the deviation which comes up in each area. So the maximum deviation, what could be found was 10 microns. By comparing from each section, from the sections to each other, there have been a deviation of just 30 micrometer, which is really unique. So this is more or less nothing. Additionally, they did a measurement, a manual measurement according to the EN 1250 standards. And we're comparing again their numbers with the results taken from the equipment. And again, they achieved a very, very low, a very high conformity. So there was just a variance of plus minus 25 micrometers over all sections. So that was really a benchmark result which could never achieved before in the industry. Giving you a quick summary of those big points from the true edge distortion technology. So this technology is based on a high resolution camera system which measures distortion every 0.5 millimeter. So it gives you really precise and very dense information about the deformation of the glass. It reached a really extremely high distortion resolution of plus minus 4 millidiopter. And what is also very important is it starts right at the glass edge, so you have no blind spots anymore. It records both millidiopter values and peak to valley values in millimeter, and it identifies all kind of distortion. And then sure, it's a modern and unique technology which can be easily upgraded and is also very extremely modular. So this equipment is really the key for furnace optimization and future advanced automation. And what are now the benefits across the entire value chain based on the technology? So for the architects, they are happy to have an enhanced transparency, confidence in visual outcome. The glass processors have an equipment where they can trust 100%. So there is no need anymore to do manual controls of the distortion. And it gives also to them the opportunity to have a stable and predictable lamination. The quality managers are absolutely happy because now they have a reliable tool which gives consistent and traceable online documentation. And the sales managers finally are extremely happy because they have the documentations to each piece of glass what they can transfer to their customers. And in general, for the whole company, the big benefit is the opportunity to reduce costly post-deliveries, complaints, and returns. So coming here to the next industrial test here. There's another customer from Germany who was implementing the technology after its furnace. So the operator could see here also immediately which glass is good, which glass is bad, which numbers are reached. And all the documentation here is done. But at the same time, there were those information at the end was also transferred to the infeed of the furnace to give the supervisor the chance to get online the same results here. So what's now the big benefit out of it? For these operators who are changing the parameters of the furnace, they get a direct feedback of what they did. What's the impact of their changes on the terms of quality? And based on that, we noticed that those guys, when they're experienced, they learn quickly. And several customers of us who are using the technology reported to us back that between 4 and 6 weeks, they already received a significant change in terms of quality. So, what's the current situation today? So, with manual furnace optimization is already possible today with this equipment. But still, you have to rely on qualified operators. But you can get a huge step forward to that vision. And how could the future look like? The future could look like that there's a direct data integration into the furnace control. So that the furnace control is capable to do continuous improvements through machine learning. So, and this brings us towards full process automation, which is then independent of skilled operators. But this is still the future. So coming back to the start of this presentation, when I talked about this quality vision for each glass fabricator, to be able to produce permanent, perfect tempered glass quality. With this equipment, you get a really high step towards this vision. So the technology, the results are driven by precise measurement and the skilled operator. Now I come to the conclusion. So the true edge distortion is today the new benchmark for distortion measurement. with full transparency and repeatability. It drives quality, efficiency, and customer satisfaction to a new level. And it is ready, as you have seen, already for dynamic manual furnace control. But it is at the same time also ready for future full furnace automation. Let me allow to finish my presentation with a takeaway for you. So let's turn your company vision into quality excellence and intelligent processes. Thank you.